All right, so from this point forward, what I'm going to be doing is going through the lesson and then going through a couple of homework problems at the end of the lesson, and I'll just keep that in one video to make things easier to find on Google Classroom. So here we go. We have a warm-up in this lesson. What we're doing in this lesson is, I'll show you here, 2.3, solving inequalities using multiplication or division. And we just have 3 examples to get through. So 3 examples, this little warm-up, and that's it. All right, you can see that I already typed out the lesson, or excuse me, the answer to this one here, and I forgot to delete this before making this video, but that's okay. Let me show you how I would derive this answer. This is just a warm-up that you would have done in class on your own. So it says, is x equals 7 a solution to the inequality? So I'm going to write down my inequality, x is greater than or equal to -2. Is x equals 7 a solution? Well, all we have to do to find out is plug in 7 for x. Substitute 7 in for x, and we get 7 is greater than or equal to -2. So what I wrote as my answer, typed out as my answer, it says x equals 7 is a solution to the inequality since it makes the inequality true. And that's true because 7 is greater than any negative number. So if you got a false statement, let's say our inequality over here was a, I don't know, a positive 12, and this was a positive 12, and that was a positive 12. Well, 7 is not greater than or equal to 12, so then I would say x equals 7 is not a solution to the inequality since it does not make the inequality true. So just in case you run into anything like that in your assignment. All right, but in this instance, we got a true statement, so x equals 7 is a solution to the inequality. All right, so to get to those examples, we are again solving using multiplication or division in our inequalities. So what we're going to do, similar to the last example, or excuse me, similar to the last lesson, we are going to solve using not only the addition and subtraction properties of inequality, but now also using multiplication and division, and we'll see how that affects things. So we're going to have to try to get all the variables onto one side of the inequality and all the constants or numbers onto the other side. So the first step I'm going to do is subtract x from both sides. And the reason I'm doing that is because x minus x gives me a 0. It eliminates it from the right-hand side. I've got my inequality symbol getting carried down here. I've got just a positive 1 left over. 2x minus x, those are the like terms. I can't combine it with the minus 5. It's not a like term because there's no x. So just combine the like terms. 2x minus x is 1x. So I can just write x. And then I've got that minus 5 left over. Add 5 to both sides of the inequality to solve for x, and we get x is less than 6. So these 5's canceled out. And now the directions say write your answer using set builder notation. So we should always be using set builder notation when our answers are a set of values, especially when there are infinitely many values. Like any number less than 6, there are infinitely many numbers that are less than 6. So I'd say the set of x. Actually, let me write this in the next line. The set of x such that x is less than 6. And that's set builder notation, which we discussed in the last lesson. So the set of x such that x is less than 6. And that's my answer. So 2 more to go. Before we get to them, I want to mention this. It says when multiplying or dividing both sides of an inequality by a negative number, you must flip the inequality symbol. So why do we do that? Well, let me show you a little example here. If I've got 1 is less than 7, and this is a true statement, right? 1 is smaller than or less than 7. But if I decide to take that and multiply both sides of the inequality by a negative, in this case I'll just multiply by -1. Well, if this was an equation, that would be true. So if you had an equation where it was like 7 equals 7 and you multiply both sides by a -1, you get a true statement. -7 equals -7. That's the multiplication property of equality. But with an inequality, it's a little bit different. With an inequality, if I multiply both sides by a negative number, I get -1 is less than -7. And that's false. The reason that's false is because -1 is closer to 0 than -7. So -1 is actually greater than -7. So if I want to make this statement true, I need to flip my inequality symbol around. And since this line is equivalent to the line before it, I need to flip the inequality symbol around in that step. As soon as I multiply both sides by a negative or divide by a negative, I flip the inequality symbol to account for that idea of now it's not the number that's farther from 0 that's larger, like in 1 is less than 7, 7's larger because it's farther away from 0. Now it's the number that's closer to 0 that's larger. So that's why we have to flip the inequality symbol to account for that whole change in idea of which number is greater. All right, so moving on to example 2. Again, just 2 more to go. It says write your answer again in set builder notation. We need to solve for y in this one. So we're multiplying by a fraction. So to undo that, I'm going to multiply by the reciprocal, -3/2, and do the same thing to both sides. But again, I'm multiplying by a negative. So as soon as I multiply by a negative number, in that step, that's where I flip my inequality symbol. So I need to flip it right away. And this one's kind of nice. 2/2. These are going to cancel out. So I have a -3 all by itself, a less than or equal to, -2/3 and -3/2 cancel, and y is all by itself. And y is solved for. So the only thing we have to do now is take into account that when we write our answers, we always want to put the variable on the left. That's just the conventional way of doing this. So we put the variable on the left. The symbol here is opening towards the y, so it needs to open towards the y. And then we have a -3. So our answer in set builder notation, the set of y such that y is greater than or equal to -3. All right, the last example I have for you today, we have to undo division. So we're going to multiply both sides by 3. But I don't need to flip my inequality symbol. The reason I don't need to flip the inequality symbol is now because I'm not multiplying by a negative, I'm multiplying by a positive. I'm multiplying both sides by a +3. So these 3's cancel. I still keep my inequality the inequality symbol the same way because I'm not multiplying by a negative. I get a -6 on the left side and a -x -2 on the right. All right, now I'm going to undo the subtraction by adding 2 to both sides. That cancels out that -2. Over on the left side, -6 plus 2 is -4. Carry down my greater than or equal to, and I have a -x. I did not solve for x yet. X is not by itself. It's still -x. So it needs to just be +x all by itself. It's a -x. So in this step, I need to multiply or divide by a -1. So I'm going to divide both sides by -1. Because I'm dividing by a negative, I need to flip my inequality symbol. The negatives cancel, and I get -4 divided by -1 is 4. Carry down my less than or equal to, and carry down the x. Now, just like the last one, the variable needs to go on the left. The symbol's opening towards the x, and now it says x is greater than or equal to 4. In set builder notation, that's x such that the set of x such that x is greater than or equal to 4, and that's my answer. All right, so the assignment is in the book. It's pages 71 to 72. So on this one, I'm going to go ahead and show you one more time. If you haven't seen my other video, if you have not seen the other video, I showed in that small video that I posted right by this lesson how to find your online textbook. But you just go to online textbook, you click on this link, and it's going to open up to, let's see if I can get back to it. I tried to get around it by opening the incognito tab, but it's not working. I can't get to the page I saw before because I've already opened this once. You might see a page that just has this drop-down menu, and you have to go to Common Core High School, not the other Common Cores. So Common Core High School, click Go, and then it would bring you to this tab. So I've already done that, so when I load this page, it goes right into here, and then click on the Algebra 1 book. But pages 71 to 72. So I'm going to go to the drop down here, go to 71, scroll down to 71. So here is the homework page, 71, and right below it, 72. All right, so on page 71, let me just go through a few of these with you. So we have 4 through 18 even, 19 and 36. So 4 through 18 even, 4 through 18, so these guys right here, and then 19 and 36. So we have number 19, a word problem, and 36, and this one is thinking about how it could make an error if something happens. So I'm going to let you think about 36 on your own here. 19, 12, inequality. I think you can probably reason your way through 19 as well if you spend a little time with it. So I'm going to go through some questions on 4 through 18. So let's see. I'll go through one from this section and one from the next one. So on the first section here, let me go through the one with the fraction on it. How about number 10? So on number 10, it's -16 is less than or equal to 8/3 t. So just like that last example, example number 3, we had to, oh, no, sorry, example number 2, we had to multiply by the reciprocal, and that's the same case here. We're multiplying by a fraction. To get that to the other side, we multiply by the reciprocal. So I'm going to multiply both sides by the reciprocal 3/8. Multiply this side by 3/8. All right, so this will give us, these are going to cancel out. P is going to be all by itself on the right side. I multiplied by a positive, so I don't have to flip my inequality. Negative 16 divided by 8 is negative 2. Negative 2 times 3 is negative 6. So again, we want to write our variable on the left side. So I'm going to say the set of t such that t is greater than or equal to, the symbol is opening towards t here, so it needs to open towards t there, greater than or equal to negative 6. So that's the answer to number 10. Then I'll go through one on one of these three, 12 through 18. 18 is very similar to number 10, but be careful when you multiply by negative, you're going to have to flip that sign around. Let's go with number 14. Number 14 says negative 15 is less than or equal to negative 3c. To get c by itself, we need to divide both sides by negative 3. But again, we are multiplying or dividing in this case by a negative. We need to flip our sign around in that step. What we end up with, negative 15 over negative 3, the negatives cancel, we get 5 is greater than or equal to, the negative 3's cancel, so we just have c. So our answer, the set of c, such that c is less than or equal to 5. So on this one, the symbol opens away from c, so it needs to open away from c down here. And that is it. If you have any questions, let me know.